I am absolutely thrilled to introduce you to my friend Tejas Kumar. We first crossed paths at JSCon Budapest, and from the moment I saw him speak, I knew he belonged on stage. And Tejas just has such incredible stage presence and a way of captivating the audience in a way that you just can't look away. And beyond from his speaking talents, Tejas is also an incredible friend. And last year, when I visited Berlin for React Day Berlin, Tejas and his wife kindly invited us to their home, and we were able to make cookies at his place. We have a picture of it.
Do we?
Oh.
Just take her word for it.
Okay, I swear we make. Oh no, this is the next. No, this is the spoilers. Okay, this is unrelated. Yes, these cookies. Okay, so that's Tejas' cookie at the top, and then there's Cookie Me at the bottom. Let's show some love for Tejas.
Thank you. Thank you, thank you, thank you so much, CascadiaJS.
18 omelets. There's 18.
Wonderful. Hey, thank you so much for sticking it out. I know it's late in the day, but we'll get through this. I am excited to give you this talk, and I hope you're as excited as I am to listen to it. My name is Tejas, as Daphne so lovingly pronounced. That's pronounced like contagious. Don't worry, I'm not contagious, as I last checked. Except for maybe, hopefully, like good vibes. I'd be down to be contagious with those. And I'm a developer relations engineer at DataStax. And what that means is I get to build really great things with AI and then talk about them at conferences. And that's exactly what I intend to do today. And if you haven't been yet to the DataStax booth, come. We have some great things to show you, okay? But today, we're here to talk about AI-generated React Server components. AI, I just wanted to play the game of how many cool buzzwords can I put in one title. And here we are. No, but it's an interesting topic I want to bring up today because I feel like we're on the cusp of evolving beyond chatbots. Okay, that's the thesis. And so what we're going to do in our time together is just like walk through each part of this title in some detail. Okay, so let's start with just AI. What is AI? This term tends to be overused and maybe even abused a little bit. You see the company valuations go through the roof when they say we built this thing with AI, and it turns out it didn't really have AI. Like the rabbit device or the humane pin or all, like these are, you know, and I'm naming them because like I think we can all agree by now that like some of them were just scams, right? And so it's late in the day, whatever. In any case, I think it's important to get some detail and nuance around the use of this term, and then we'll form the good basis of a discussion to go from there. So what do we mean by AI? AI isn't necessarily new. AI has been around for a long time, decades, even 1 century, maybe. And this depends on the definition, but fundamentally there are 3 types of AI, right? There's rule-based AI, where the rules are known ahead of time and programmed into the program by an engineer. So things like Pac-Man, right? You've got ghosts that chase you, and then when you eat like the berries, they turn blue and avoid you. Like those rules were programmed in by an engineer ahead of time, and the game follows them. Similar things are like Mortal Kombat, right? Where you fight against a CPU player. That's just rule-based AI. And it is indeed AI. It's artificial intelligence. It's an intelligent system that can like fight you if you're Sub-Zero. Scorpion goes, get over here, you know? Rule-based. There's predictive AI. And this finds its roots like in a 1906 paper published by one Andrei Markov, right? About statistical models that can predict the next likely scenario. And fast forward many years today, if you have an iPhone or an Android, this sits above your like keyboard. The next word suggestions are basically a Markov chain, a predictive model that is an artificially intelligent model. And so it can guess the next word, but if you keep repeatedly tapping on the next suggestion, you end up with somewhat of a nonsense. I don't know if you've tried this, but there was a thing that we used to do on Twitter where you just like tap the next suggestion repeatedly and then post it, right? It's a bit nonsense, and that's because of the Markov property with Markov chains, which is they're memoryless. They take the current word and use the current word to predict the next word based on a large data set. And because there's a lack of memory and a lack of attention, you end up with not the best next prediction. Generative AI is the AI that gets everyone excited today because it offers novel inventions of new things that we innovate lots of novelty there. But it's founded in this, we just saw this actually in a previous talk by Jacob, in this paper, 2017 hallmark paper, revolutionary paper by Google called Attention is All You Need. And it introduces a mechanism that is literally what it sounds like, dual-sided attention that can pay attention to input tokens and the order they're in parallel to not just track the next word from the current, but get the next word in relation to context by paying literally attention, mechanistic attention, to your input tokens to predict your output ones. This led to the transformers architecture that, as we saw in the previous talk, gave rise to GPT-2, 3, 3.5, ChatGPT, and the world was never the same. So that's Gen AI. Generative AI is the AI that we're here to talk about. Not rule-based, not probabilistic or Markov chain-based AI, not predictive AI, but Gen AI. Gen AI. Anyone use Gen AI here? Can I see your, like with ChatGPT or whatever? Okay, that's like almost everybody, yeah. Who here recognizes there's problems with this? Right, yeah, literally everybody, look at that. There's plenty of problems with Gen AI. Google is rolling out this like AI overviews thing, and I'm sure you've seen the memes on social media where this thing just gets things confidently wrong. Like somebody typed into Google, like, how many cigarettes should a pregnant woman smoke per day? You saw this? And the answer was 0, of course, is 0, but the Gen AI, the Google prediction was like, oh, it's typically normal for a pregnant woman to smoke 1 to 2 cigarettes per day, right? And it just said it like with authority, you know? And so it's a huge problem because like it's Google. You want it to be authoritative. And so a big problem with Gen AI is this hallucination. They see things that are not there, and they serve you this content somewhat confidently. Of course, we perceive the confidence. They don't have such a concept. We're anthropomorphizing. I said that first take. That's awesome. But they tend to hallucinate. Number 2, they have a finite context length, meaning with enough duration of discussion, they sort of start going loopy and they lose context. Of course, there's larger models like Gemini with a 2 million token context window. And if you're not so sure about tokens, they're roughly equivalent to like 1 English word, okay? So 2 million English words, that's a lot, but it's not like your entire life as narrative to be a smart, like a Jarvis-style assistant. So it's still somewhat limited. And I think probably the most diabolical is there's just like the training date, and past the training date, there's no new information. And so there's no like real-time information. You can't go to ChatGPT and be like, hey, should I take an umbrella? I'm about to head outside. It'll be like, as per my knowledge cutoff on this date, I don't know. And so that's not very useful. And so how can we fix this together? Well, there's a technique called RAG. Again, we just saw this in Jacob's talk. I won't go into too much here. It stands for Retrieval Augmented Generation. And what it means is exactly what it sounds like. You retrieve data from somewhere, and you use it to augment the generated output from a large language model. That's it. You get data, you say, hey, ChatGPT, here's some context, generate text based on this. That's it. You can get data from wherever you want, in whatever programming language you want. It doesn't matter. You just get context, give context, get real time, ideally, generations back. Is that clear so far? Good. Okay, so this is the way you bring real-time insight into a large language model whose knowledge cutoff has passed. There are some components of RAG. You'll find these pretty much everywhere you see RAG. They're in the same sort of embedding space, okay? And that is data. Obviously, if you want to get like, if you go to ChatGPT and say, hey, convert $100 into euros, it will say, I don't have the current exchange rate. So with RAG, you'd get the exchange rate. Here's the exchange rate, so now do it. So you need that data. You need that exchange rate from somewhere. Second, embeddings models. These are specialized machine learning models that can take natural language, a single word, like hot dog, or a sentence, like where do I get a hot dog, and turn it into a fixed length array, a list of numbers called a vector. These vectors exist in what is called high-dimensional space. And if you think about dimensions, there's 2-dimensional space, right? There's 3-dimensional space with depth. Imagine 1,536 dimensions. The human mind cannot comprehend this, okay? But they take a word, a phrase, a sentence, a book, and add them together into a list of numbers of that length, 1,536, as a size. So it's an array with always a fixed number of elements. So they would take a word, you'd get a 1,000-length array, a sentence, etc. And then these arrays can be compared for similarity in this high-dimensional space. So words like hot dog and pizza and food would be sort of over here in the high-dimensional space, and words like JavaScript and Python and Rust would sort of be over here. So then you send a prompt, what programming language should I learn? It will look over here where the other programming languages are and give you an answer based on proximity. Is that clear? So that's what vector search is. You'll see this a lot with RAG. And then finally, a vector store. So you get these big lists of numbers, and you need to put them somewhere. And ideally, the place where you put them has a similarity search engine. This is pretty ubiquitous with almost every RAG setup, okay? And I'd like to show you all of that in action right now. So let's exit out of the presentation. Oh my gosh, we've broken the wall. And let's go to my command line and open up LangFlow. LangFlow, you just saw the talk about LangChain, right? LangFlow is sort of like graphical LangChain. So it's so cool that I'm after Jacob, okay? This is what RAG looks like. This is what a RAG pipeline looks like. So if you'll follow me here, this is the diagram. So you start with a chat input. This is literally like something you write. Hey, should I take an umbrella outside? Who won this? What's the score of that? Which movie won Best Picture, for example? You also take an embeddings model. We just talked about this, right? It converts natural language to numbers. Okay, you take these, and you connect the text from the chat prompt as the input value to some vector search engine. We're using Astra because that's what DataStax makes, and we try to make it the best vector search engine in the market. So you connect your chat input and your embeddings model to AstraDB search, and of course you add your application tokens and secure stuff. You then get the response, and you break it down into chunks, like understandable portions of text so we don't overwhelm the language model. Then you construct a prompt, and this is the ultimate RAG prompt. Check this out. It says, use this context to answer this question. Context comes from the vector search database. The question comes from the user's chat input, okay? And then when we generate a prompt, we send it to a large language model, in this case GPT 3.5 Turbo, and we get a chat output. This is the whole RAG pipeline visualized. If we're happy with this, we click on the API button here, and it becomes like a HTTP endpoint that we can just query from a front end. Okay? But let's look at this in action. So if I go to the playground, and I ask a question, a time-sensitive question. Who won the Oscar for Best Picture in 2024? What are you going to say? The answer is, in order to find out who won, you need to look up the information online. Wow, thank you. Okay, but let's fix this with RAG. So remember, we talked about LangFlow being this sort of pipeline builder that's visual. Just like you can have a read pipeline, you can also have a write pipeline. So if we come here, this is my ingestion pipeline, okay? And what you can see is I just have a URL to this page. This is the British Film Institute, and they have a blog post about who won the Oscars. So I read this URL, and I break it down into chunks of about 1,000. And the reason we break it down into chunks is because we want like many portions of text so we can search for the right one. Who won Best Picture? We can do that proximity search among smaller portions of text. So we break it into chunks. We take the same embeddings model from the read flow, and we plug all this into AstraDB. So what we're going to do when we hit play is we're going to like crawl that website, break its text content into chunks, and store it in AstraDB. That took 1.59 seconds, okay? And now I've got the data. And so if I now, from AstraDB, go to the playground again, and I'm like, who won the Oscar for Best Picture in 2024, we will see RAG in action, which is Oppenheimer won the Oscar for Best Picture in 2024. Fantastic. This is RAG. We bring real-time information into a large language model by getting the data from somewhere, ideally a vector database, and serving it. But we can do better. Since we have the context, we can say, what are some other highlights of the Oscars 2024? And now, let's see. I don't know. I actually don't know what's going to happen. But some other highlights are Emma Stone won Best Actress for her role in Poor Things, and all of this information that is past the knowledge cutoff just because we fed this one web page as context through that initial pipeline. Is that clear? So that's RAG in action. That's how you can like take something as powerful as ChatGPT and make it special, make it real time. Imagine you work at a company that has a ton of customer data, like preferences and things. You can literally like tailor it to your people using RAG. Okay? So that's RAG, but I can already like hear some of you, sort of start to scoff at me and go like, okay, cool, but Tejas, it's called CascadiaJS. Where the JavaScript at? And it's okay, I got you. So remember, these were the problems with GenAI. We just effectively solved all of them with RAG. There'd be one more problem with GenAI, and that is LLMs produce mostly text. And I don't know how you feel about this, but I'm pretty tired of like chat interfaces. I think they're overdone. I want to provide the users with richer modalities of content. And so this is where we enter the realm of React Server. So the title of this talk, AI generated, we've been there, React Server components. And specifically, what I'm talking about is generative UI, not Gen AI, but Gen UI. And I'd like to show you that now in a little live-coded demo. So what we're going to do is together build a nice chat interface that does similarity search. And to highlight my problem space, let's go watch Netflix, OK? I love Netflix, but sometimes when I want to watch something, I search for things like movies, like with a strong, let me make this bigger, strong female lead, for example. This is how I search. I search for like what I want to watch. I don't search for like the name of a movie. I'm like, I feel like an adventure movie. And oftentimes, unfortunately, this doesn't give me what I want, as you can see. It's kind of sad. So what if we build our own like semantically sensitive search for movies? And so I've sort of started this with a little thing. It doesn't do anything, but we'll build this together in like the 10 minutes we have, OK? Hopefully. So this is our application. And to actually enable AI here, what we need to do is just create a file. We'll call it ai.tsx. And we will, is the font size OK? Can you see that? And so what we'll do is, this is a server component. It's actually a server action. So we'll use server. And we're using React here. Anyone use React? Just to make sure I'm not. OK, all of you. Great. So we'll export AI. Export const. Look, it's JavaScript. Be happy. Export const AI. We create AI. And we're using the Vercel AI SDK. It's truly a great piece of engineering. So what does this want? Well, it wants some actions. We'll get to those in a second. It needs an initial AI state and an initial UI state. That's it. And now we have an AI context. What we'll do then is we'll go to the outermost level of our application, the layout, and we'll just wrap the entire thing in this AI context to make it context-aware, just like this, OK? We're almost done. So now what I want is when you click on like one of these prompts, I want it to actually search. It doesn't do anything. Let's fix it. So this component is called a suggestion, and the suggestion calls a function search on click with use movie search. What does use movie search do? Literally nothing. So let's fill this in together. What we want is a function, an action called continue conversation. We'll define this just now, and we'll say use actions. Okay? And what we also want is a way to like set the conversation state. So we'll say set conversation, and we get this from use UI state. These are hooks given to us by the Vercel AI SDK. They're great for building user interfaces. Okay, so now, and it works with Next.js, which is sort of the premier way to build React apps, et cetera, et cetera. Okay, so what do we want to do? Well, we want to first set the conversation to the conversation and the prompt. But for the prompt, we'll say it's of type user, because the user is submitting this, and its content is the prompt. Excellent. We're just going to, if Josh Goldberg is looking, I apologize. And then we'll get the response from here, and we'll actually also send that prompt to continue conversation. What's funny about that? OK, anyway, so then we set the conversation. When we get the response, we just set it here. But instead of all of this, we'll just set the response as the response to our previous conversation. Exactly. This looks good. So now it's sort of working, but our action isn't defined. So let's go define that back in our AI context. So it wants actions. We literally said call an action called continue conversation. So we'll define that. Continue conversation is an async function that gets the prompt and does something. OK, what does it do? Well, we can get a result, and we'll call a function called stream UI. And this function gets a model. So you can choose what large language model you want to talk to. OpenAI, Anthropic, et cetera. We'll just use OpenAI here, because I tend to just, it's the most idiomatic to me. We'll go OpenAI, and we'll import this from AI SDK OpenAI. Now, we have the OpenAI, and we'll choose our model. Let's choose GPT-4o, because it's like the latest. Then we have messages, and the messages is really the context. Okay? And if we're continuing the conversation, then what we should do is actually continue it, right? So we need the history. So we'll define the history as get mutable AI state. And here, we'll spread the previous history, and we'll add new history. So we'll say the type is user, and the content is the prompt. So we're just like, we're calling stream UI, and we're giving it this context. This should be more than enough for what we want. And now what we'll do is we'll return an object. We'll say the ID is just a unique ID, so we don't confuse anything. We'll say, what? Why is that? OK. We'll say type is assistant. And the display is the results value. OK. So we're just like querying GPT-4 and returning some stuff. Finally, we'll go to our page and actually make that. We'll use the result. Instead of an empty array, we'll just like use UI state. Okay. So we did a little bit of coding, but let's see if this works. So we come back, we reload the page, and we just click on the first prompt here. There's an error. It totally doesn't work, but it's okay, I came prepared. What's the error? Invalid role undefined. Oh my goodness, how dare I? Type user, where is it? Maybe here? Oh, it's type. It's role, my mistake. Gosh, this is why we need TypeScript. Okay, let's try this again, and we'll do movies with a strong female. Oh, it's, what do you want? Invalid role undefined, gosh. Did I do type in some other place? Thank you. My ability to recover from, okay, let's try this again. So there we go, so it worked, and it's generating me a list of, but this is actually, honestly, it's working because it's like giving me the semantic results, but it's sort of worse than Netflix in terms of UI. And also, let's ask like which one is the best. And now it's like the best option depends on the context, and it's like the best travel destination, the best book, the best program. It doesn't know that I just talked about movies. We can fix that. So let's pull on this thread a little bit more. If you're returning me text, then I'm going to get done and the content. And if you're done, then I'm going to call history.done, and I'm going to pass in the context, just like this. Okay? So I'm going to say, I got this from the assistant, we're done here. Persist the text content. And I'll also just return the content. Okay, let's try that again. And let's reload. Try this. Okay, it's still giving me like this pretty ugly text, but I think we're going to be okay. So, gosh, that really is hard to read. Okay, which one is the best? And so now what you can see is determining the best movie. Gosh, that's moving really fast. Determining the best movie is for superhero fans. You want Wonder Woman, etc. But it's still a bit unreadable. So let's maybe fix that by wrapping this in Markdown, like that. And what you'll notice is, yes, I can actually put React components in here. Isn't that wild? So let's try this one more time. Movies with a strong female lead. And now, oh my gosh, it's like readable. Incredible. So we're serving rich UI, but I really think we can do better than chatbots. I really think we can do better. So let's make the UI a little bit more intuitive. We care about the experience. So instead of text, let's use tools. And what we'll do is we'll define a tool called getMovies. Okay? And this tool has a description. So when a user asks for movies, call this tool. We're literally telling the AI when to call this. It has some parameters, and for this we're going to use Zod to validate the parameters. So we'll just import Zod. And we'll say it's an object with a property, I don't know, prompt, and it's a string. Okay? And finally, we need like an actual generate function to get this for us. So we get the prompt, and we need to return something. We can return React components here from the server, React server components. So let's instantiate our client. We'll say new data API client. We'll import this from DataStax. Again, we're importing from Astra because our database can do similarity search, and that's kind of what we want. So we'll import the data API client like this. And we'll do process.env.astra.db application token. Whoa, great. And then we'll get the database. So we'll do db equals client.db, and we'll pass the, not that, AstraDB API endpoint, like this, okay? And now we have access to our database, so we can do whatever we want. We can literally say data is await db.collection movies, movies.find, and we'll vectorize. We can literally convert the prompt into a vector embedding on the fly and say we want the 4 top movies, and we'll convert that to an array. Okay? And so now we have this data. Let's, again, insult Josh Goldberg a little bit. And we'll just return a React component called movies, where movies is the data. And so this React component, by the way, is like a client component. It's not even a server component, but it does render initially on the server. So now if we come back, movies with a strong female lead, what we get is not so much, oof, you see this? This is so much, but this is sort of the experience I want. And if I click on it, I get taken to like the page with the trailer and everything, and I can just watch but we can do even better. And we'll finish with this. I realize I'm almost out of time, but let's fast forward and take this full circle. We just go to the main branch, stash. Okay, check out main. Because I have this working really nicely on the main branch. I want to show you main. And we'll npx next dev. And now let's come back here. And I want to show you this thing in sort of like its final form. It starts off its life as a chatbot, but you can say like romantic comedies in Europe, okay? And I'm gonna hit enter and search. And so there's a big list, but I don't like this modality, so I'm like, what might this look like as UI? Maybe I'm a UI designer and I want to see. So it's going to fetch the movie posters. There you go. So these are some romantic comedies from Europe. And I'm like, OK, that's cool. Show me the trailer for Notting Hill. And we can, why not? You know, we can even do like video and you just like embed it like right here. Yeah, thanks. And so we can, and then like, what was the critical reception for Notting Hill? And when we do this, we can just bounce back to text. And so we finish the story, right? And so the modality really is, in this case, in service to the user. We're not building yet another chatbot. We're serving the user what they want, hence using JavaScript for its intended purpose. OK, we covered a lot of content. Let's wrap up. We started out with the title of the talk, AI-generated React server components. We talked about AI. We talked about rule-based and predictive and gen. We talked about generation. We literally looked at RAG as a way to fix the problems with AI. Those movies, by the way, were RAG. We were using Astra. We were using Langflow. Okay? So AI generated and then React server components. We literally, in like a few minutes, wrote some code that generates that React component on the server, streams it all the way to the client device, and the AI itself calls the function that returns those. So truly, AI-generated React server components. If this is interesting to you, I'm teaching a workshop tomorrow, but I think spots are full. In any case, I'm here today, tomorrow. I'd love to talk to you more about this. Come by the DataStax booth, CascadiaJS. Thank you so much for having me.